Hi, I'm Travis. I'm going to be talking a little bit about Beyblades. This is an indie lab by me and Rashawn. We titled it Having a Beyblast, and we found that there's really a whole lot to talk about with Beyblades. And so we're just going to dig right in. So the first thing we wanted to do is we both played with Beyblades when we were younger, but we didn't have a whole lot of what we were looking for. But one thing we talked about was in rotation and angular momentum, there's a coefficient, and it's different for every single type of object you've got in every different shape. And with a hoop specifically is the best, where all the mass is centered on the edge of the object that you're spinning. And it's the same as like a mass on a string. It's really like where the mass is situated, right? And so we were wondering with a Beyblade, what would that coefficient be? The closer to 1, the better. The more of the energy put into it is going to go right into spin. So we thought, let's see how they work, because first of all, we don't know anything about how they work. We wanted to know if there were any special design things, and then what I talked about earlier is we were wondering what the coefficient Beyblade is in the moment of inertia. And that's really what we were looking for when we just dug in. So the first thing we had to do is we started taking them apart, which I learned a whole lot about. This right here is a wrench. It's not a ring. I got it stuck on my finger, and that was bad. Don't do that. Here are the principal parts that it breaks off into. There's this tip, and the tips change a whole lot. Not a whole lot on the moment of inertia, but they change a lot on how long it spins and how it spins. So we don't talk about that a lot in our lab, but that's really something you could dig in if you ever need another idea for an indie lab. This right here is the little centerpiece. It keeps everything together. The basic one doesn't do a whole lot, but there are some other weird ones that add height to it and do things like that. This metal piece is the biggest reason the Beyblade works, right? Because plastic doesn't weigh very much, which means it's not very good at distributing mass, keeping a lot of inertia. It's just not a great thing. Which is why off-brand Beyblades, when they use plastic, they suck. Never use an off-brand Beyblade, they suck, just bad, don't do it. This right here, this metal, which Doc says is lead, I'm not sure if I believe that, and that makes me slightly scared to be holding all these, but whatever.
And chewing on them. Hmm? And chewing on them?
I don't chew on Beyblades.
Thank you.
I try not to.
Neither do young children.
So this right here, and the edges on the outside of this are also how collisions happen. That's another thing we didn't get to study. But the edges really change how they bounce off of each other and do all the random collision. That's another interesting thing that we didn't get to dig into. This little plastic thing, I call it the hat, and it goes in there, and it's what the spinner hooks onto so we can spin it. And then there's this little nut that goes in and keeps everything together. So that's kind of the construction of the Beyblade, but how it launches I find to be incredibly interesting. This is a picture of a launcher with the top off. All right, so you see these two little slots here? This is where your ripcord would go in, and you'll notice this is a gear, and it's got this little paddle here stopping it. So right now it can only rotate this way. So when you just are holding a launcher, it'll rotate one way, not the other. So you put the ripcord in, it pushes in, and it pushes this paddle, so you can push it all the way through, and now it's ready to go. Then you rip it as fast as you can. So the other side of this thing is attached to little hooks that dig in and grab the Beyblade. When you pull it this way, the little teeth latch onto the spinner thing, it spins this really fast, spins the Beyblade really fast, and it gets it going. But as soon as the ripcord leaves this paddle falls down. There's a little spring here, and it stops it, which means it can't rotate this way anymore. So when it comes to a dead stop here, the Beyblade still has momentum, so it jumps off of the little hands that are grabbing onto the top of it, and it flies. And so this right here brings it up to speed and lets it just launch off of there without it, doing other things. It's really interesting. There's a lot of design things in here, and it really looks simple, but I just love how all of this works. It's just so cool. We actually had a thing where one of the launchers we were using consistently performed better, and we had a problem where we couldn't figure out why this one launcher was better than all the rest. And it also worked differently. Whenever we'd rip it, sometimes it would just stay on the launcher, and we couldn't figure out what that was about. So we looked in there, the spring was off, which means this paddle was never stopping it, which means it never had like a drop in how fast it was spinning, but it also means it never had that stop that makes it kick off of the little hands. So if you ever want to cheat in a Beyblade competition, that's how you want to do it. You want to spin it really fast, break the spring, so it'll go really fast, and then kind of flick it, so it'll come off. People might notice you're cheating though, so I wouldn't do it, and I don't bet on Beyblade battles. So there's a really long derivation that Rashawn is really good at, but I don't want to waste your time in showing you all of it because we're going to talk about it on the grass. But essentially, our process was we had screwdrivers, high-speed cameras, and force gauges is a lot of what we did here. We had 3 different Beyblades that we looked at, and we had a high-speed video of the Beyblade from above. Okay, so we got, the video is really just going to help me explain this all. So we're going to do that real quick. Red. Cord. Was this where it was? Yeah, there we go. So this is just fascinating to me. We got a really high-speed camera that Doc has. We had to actually up it a little bit because Beyblades rotate really fast. we had to try to slow down how we were doing it. Is this even play? Yeah. It's kind of hard to tell. But they actually rotate at like the slowest we could get them to go was 20 times in a second. So right here you can see, I think this is Rashawn pulling. This is a force gauge. We're pulling the ripcord with the force gauge so we can measure the force. That's someone holding it. I think that's also Rashawn. Move it out of the way, and then you can see that's so slow motion. You saw, like the whole time before this was me just saying let it rip. And so you can imagine how fast this thing is really going. This is a little sticker of a milk carton, so you can kind of, so we can later go back and count the rotations. But just look at that. Isn't that cool? So it moves around a little bit, which we thought might be a problem, but it really isn't because the amount of force that goes into it moving is considerably less than the amount that goes into it spinning really quickly. So that's that video. Where is this? So we had a camera above, we had the force gauge for pulling it, and then we did video analysis, and that's the majority of what we did. So these are the graphs we got. Here's the position, so we could get the speed of it and the period. This is graphed on the x and y axis. This is specifically the sticker. Then we took the integral of torque, which is just finding the area under a graph. So this is the force sensor. It goes really big, and then under there is how much force we put into it. And so here's where we got the mass of each Beyblade. We had the original, which is just kind of your old standard Beyblade, probably what you're thinking of. We had Shorty, which was a really tall Beyblade because the center was just huge and it was interesting. And then we had the Spin Master, which had a little spinny thing on it. And looking down over here, we have radius, period, actual period. The actual period is different from the period because the process that we used to analyze the video thought we were using a regular camera, so we had to adjust it. Then there's another problem we have with the radius, but I won't go into that because it's really technical. But eventually, right here is what we're looking for, coefficient Beyblade. So you'll notice 0.86 is really good because 1 would be like impossibly perfect, right? It'd have to be an actual hoop. Then we got 1.05, which is better than possible. So that was kind of a little worrying for us, but we think either they're magic down at the Beyblade Company, or we got a little bit of error, which is probably more likely, and this is 0.9. So these numbers, while this one is probably impossible, are all very good numbers. That shows that they know what they're doing when they build them. In result, coefficient's about 1. It's because of the mass distribution being mostly in this little metal ring. We probably didn't, they may not be perfectly symmetrical. We may have measured the wrong radius. We don't know exactly where that came from, but we have a pretty good idea that we got a pretty good job on the thing. So Beyblades are super complicated. There's a lot of stuff you could do on them, and they're really well made, actually. So that's all I have.
Could you show the equation in which there is a coefficient Beyblade? Like, where should we be framing this thought about the coefficient?
See if Sean has it just real quick. It's written on a piece of paper. I don't have it right now, but it's essentially I equals. Do you know the equation?
On the board.
It's moment of inertia. It's I equals some coefficient mv squared. Is that right? I don't know. Mr squared. I think that's it. So this coefficient changes based off what object you have, and we were looking for what this was specifically for Beyblades.
Does I don't know if you actually looked at this or not. You said that you didn't spend too much time on it, but obviously you're very familiar with how Beyblades work, more so than I am. And I was wondering if the little piece on the bottom, the pointy one, that's what keeps it off the ground. And so did you look at all at how the height of the Beyblade, like off the ground, because like the metal ring is sort of at the top of the Beyblade. Did you look at how the height of that ring affected how fast it spun, or did that have any effect? Did that have any
That's
effect?
part of what we were doing when we looked at 3 different Beyblades. We looked at the Spin Master, and Shorty is what we called it, was like this big as compared to like this big. And that was definitely changing the height of the ring. It didn't appear to have a huge thing. From just what we looked at, we think the mass of the metal ring is really the most important thing for giving it a high moment of inertia. As far as winning battles, we found that the tip had a lot to do with that because it changes how fast it loses that energy that you give it.
And that's due to friction of the
Yeah, it's
thing.
definitely a lot due to friction.
Cool.
Okay.
Did you look at any of those like little metal cheater Beyblades? You know,
the ones that I said are off-brand. A lot of those are, they have little metal rings on them to make them look more legit, but the metal rings are actually a lot smaller than these, and we found that they were just crap.
I think they're actually Beyblade brand.
The bigger, or which
they're
ones are you
really
talking
tiny. It's kind of irrelevant. I'm just curious because I had one of these when I was a kid. The like the rip box is smaller. Different kind of ripcord, I think, but like it's all metal.
Oh, we didn't
It's
see
a lot
any of those.
heavier.
I imagine those would be. Ooh, because in the center is also metal, which might actually slow it down and get it closer, and less like a hoop. I don't know. That would be interesting to look into. We didn't have any of those, I don't think.
Cool. Thanks again, Travis.
Creating special design things, and then what I talked about earlier is we were wondering what the coefficient Beyblade is in the moment of inertia. And that's really what we were looking for when we just dug in. So the first thing we had to do is we started taking them apart, which I learned a whole lot about. This right here is a wrench. It's not a ring. I got it stuck in my finger, and that was bad. Don't do that. Here are and it's the same as like a mass on a string. It's really like where the mass is situated, right? And so we were wondering with a Beyblade, what would that coefficient be? The closer to 1, the better. The more of the energy put into it is going to go right into spinning. So we thought, let's see how they work, because first of all, we don't know anything about how they work. We wanted to know if there are principal parts that it breaks off into. There's this tip, and the tips change a whole lot. Not a whole lot on the moment of inertia, but they change a lot on how long it spins and how it spins. So we don't talk about that a lot in our lab, but that's really something you could dig in if you ever need another idea for an indie lab. This right here is the little centerpiece. It keeps everything together. The basic. Hi, I'm Travis. I'm going to be talking a little bit about Beyblades. This is an indie lab by me and Rashawn. We titled it Having a Beyblast. And we found that there's really a whole lot to talk about with Beyblades. And so we're just going to dig right in. So the first thing we wanted to do is we both played with Beyblades when we were younger, but we didn't have a whole lot of what we were looking for. But one thing we talked about was in rotation and angular momentum, there's a coefficient, and it's different for every single type of object you've got in every different shape. And with a hoop specifically is the best, where all the mass is centered on the edge of the object that you're spinning.